Okay, so let's do the last 5 rules of replacement, which will give us 18 rules total. So we have on the screen here transposition, implication, equivalence, exportation, and tautology. And remember these 4 little dots here, what they mean is equivalent. So if P then Q is the same as if not Q then not P. And that's the rule of transposition. So I'm going to spend about a minute or two on each of these. Let's take a look at transposition first. Transposition, you can see I drew a truth table for it. If P then Q is the same as if not Q then not P. The truth table verifies that. So in row 1 they're both true, row 2 they're both false, and row 3 and 4 they're both true. So they do seem equivalent. You can also substitute in content. So if I'm singing then I'm happy is the same as if I'm not happy then I'm not singing. All right? And you can substitute in your own content to help you remember this important rule. The strategy here with Hurley, transposition can be set up to use a hypothetical syllogism. So in this proof we're trying to get if A then C, and we have if A then B. So if we could get if B then C, and if we can get if B then C, then we can set it up, and we can on line 2 using transposition. So transposition is really nice because you can just flip the antecedent and consequent as long as you change the tildes. Right? And then so you preserve the horseshoe and you just flip the antecedent consequent but change the tildes, add a tilde to each. Hurley strategy 2, you can pause it if you're interested in looking at that, but you can see it can also be used to set up a constructive dilemma. Okay, so study those Hurley strategies in your book. They are very helpful. Okay, let's see here. I'm going to rotate the view so you can see this, and I believe we need to go, oh, that was wrong. Let me go back and rotate it again. Clockwise, and one more clockwise should do it. There we go. Okay, so the next rule is material implication. And you can see here it says if P then Q is the same as not P or Q. So I drew a truth table here to verify that. You can see each row they have the same truth values, so they're probably the same. Also, if you think through it for yourself, remember if P then Q is only false when P is true and Q is false. Right? So this would not P or Q is only false when P is true, so not P is false and Q is false. This captures that. Right? And you just need to think through it and see it for yourself, kind of meditate on it. Okay? And then plug in your own examples. If I'm clogging, then I'm happy is the same as I'm either not clogging or I'm happy. Okay? Now this strategy, and by the way, it's important to remember that we're using the inclusive or up here on the top. Okay, so this strategy can be used in many ways. Here's a couple ways. It can be used to set up a hypothetical syllogism. So notice premise 1 and 2 are not A or B, and then not B or C. And that's precisely this form right here, not P or Q. So we can just switch them to if P then Q. Right? So number 1 becomes if A then B, number 2 becomes if B then C. And then when we have that, we can do the hypothetical syllogism. Okay, the other strategy is kind of cut off, but if you have a statement like if A then not A, you'll really just go crazy trying to solve it unless you remember what a tautology is, the rule of tautology. But first you want to use the implication, say not A or not A. And then tautology says that when you have not A or not A, you can simplify it to not A. Okay? If not A or not A is true, then not A must be true, in other words. So you can't see it here, but you have 2 steps. One's implication, one's tautology to get not A. Alright, let's do the next one. And I'm going to rotate this again for you. Try to remember which way and that wasn't the right way. Okay. So let's do it again. And one more time. I did it the wrong way. Great. Okay, there we go. So the next rule you can see here is equivalence. And this is when we have if P, if and only if Q, is the same as if P then Q and if Q then P. Now that's the same as the definition of material equivalence given earlier in the book. And the second is easy to remember by recalling the 2 ways in which P, if and only if Q, are true. Think of the 2 ways that this is true. If they're both true or they're both false, if P is true and Q is true, then this is true, this biconditional. If P is false and Q is false, then this biconditional is true. Right? So either P and Q are both true or P and Q are both false if this biconditional is true. And that's precisely the meaning of the statement. Either P and Q is true, or not P and not Q is true. That is, either P and Q is true, or they're both false. Okay, so here's a truth table verifying all of this. You can see all three statements have the same truth values. And then some examples. I'll jump if and only if you jump off the cliff. So if I jumped, then you jumped. And if you jumped, then I jumped. That's formulation 1 up here. And then formulation 2, either we both jumped or we both didn't jump. That is the case if this kind of statement is true. So hopefully that makes sense. How do we use it? You can use it in many ways. But usually you'll use it to set up the horseshoes, right? So you can change this S if and only if Q to if S then Q and if Q then S, right? And then you could simplify or do whatever you want with it, right? You can see here we use commutation, and then simplification, and then got not Q from the not S in premise 2. But once you have it in the conditional form, the possibilities are endless. Okay? And let's see here, we have exportation, which is next. Okay, so exportation is a very interesting rule. Think about this. If it's true, if we have both P and Q, then we have R. That's what this first statement says. If we have both P and Q, then R is true. And this is equivalent to saying if we have P, then if we have Q, then we have R. If we have P, these two are equivalent. If you don't believe me, look at the truth table. You can see they have the truth values, same truth values on every row. But you can also think through it with content. So we have if I'm singing and clogging, then I'm happy. If I'm singing, then if I'm clogging, then I'm happy. Right? Those are equivalent. Or if it rains and it's rush hour, then there will be accidents. Would be the same as if it rains, and then if it's rush hour, then there will be accidents. Right? So those are the same. Now how do you use this? Well, use this whenever, well, not whenever, but most cases when you see something that has two conditionals, two horseshoes like this, you can change it to this and vice versa. And with practice, you'll just get used to seeing when to apply exportation. So use it to set up modus ponens or tolens. Here's an example. We have A and B then C, A, and if B then C. So if I apply exportation to 1, then we have if A then B then C. We already have A, and that gives us B then C by modus ponens. You can also use it with modus tollens, as you can see down here. Okay. Alright, let's do one of the strangest rules, one of the rules that a lot of students forget that can make their lives a lot easier. Okay, so when you have P, you can change it to P or P, right? So if it's true that I'm singing, then it's true that I'm singing or singing, because we know one of the disjuncts must be true, I mean, namely both of them, right? Or if it's false, then it must be false. Or if it's true that I'm singing, then it's true that I'm singing and singing. Okay, this is just a basic axiom kind of logic here. Just think about it. It's just so simple you might overlook it. But what a tautology does in a proof is it helps us eliminate redundancies in conjunctions and disjunctions. So sometimes we'll reduce something after we use distribution and simplification and stuff, and we'll have something crazy like P or P. So for example, if we had if P then not P or something like that. Okay, so if we had if P then not P, we could use that, we could change that using implication to not P or not P. That's great, but let's say we're trying to prove not P. Okay, all you have to do here is remember the rule of tautology, which says when you have not P, you can reduce it. When you have not P or not P, you can reduce it to not P. Okay, so that's why it's useful. We want to reduce those redundancies, simplify them. Okay, so there you have it. Those are your new rules, and let's do a proof here. So we have this awful proof, and you could use exportation number 1 right away. You should, well, maybe you could. You want to think about that a little bit. Okay, could you use that? Well, think about that for a moment, because it doesn't take the exact form of exportation, right? if you look at it, the parentheses are a little bit different than what exportation says. Okay, but there are several. You're trying to get I, so if you could get not C, that might be a start. In fact, let's do something like this. Let's change 2 to not C or not C. Sounds like Nazi. It's not C though. Okay, so this would be 2, and we use the rule that we just learned of implication. Okay, so let's put I am. You could just put imp. That's kind of neat. Okay, now then you can use let's make sure we got that there. Yeah, you can use tautology to get not C from 3. And remember, we want to get not C so we can apply it to premise 1 and see where that leads us. The reason I'm doing that is because I'm getting closer to isolating the letter I by getting rid of the basically the C here in the little horseshoe. I'm going to do that through modus tollens. So when I apply 4 and 1, so let's put 1 and 4 modus tollens, modus tollens, then you get not the case that if I, then E. So I'm getting closer to that I at the conclusion. Okay. Now take a look at this. It's not the case that if I, then E. There's this horseshoe. If I got rid of the horseshoe using implication, then maybe I could apply De Morgan's and maybe get something close. Because if we could change this to an or, we have a not outside of the parentheses. And maybe you can use, remember De Morgan's, you can change an or to an and to an or. Let's just try that. That's just an intuition right now. Okay, so we have not the case that not I, right? And we're going to change the horseshoe or E. Implication is a wonderful rule, and that's 5 implication, especially if you don't like horseshoes, right? Okay. Okay. Now look at it, and we can apply De Morgan's rule. It's nicely set up. So we have for 7, not I, not I. I'm sorry, because this is how De Morgan's rule. Look at De Morgan's if you've forgotten this. Not I, and not E. All right, and this is 6 by De Morgan's rule. Okay. So now, you might as well do that step where you do double negation here, right? Or we could just simplify first. Let's simplify first. Not I, right? And that is from 7 from simplification. Okay, S-I-M. Oh, that's a big M. Okay. And then, remember, we're trying to prove I. So the last rule would be double negation on 8. And we got I. So as you can see, this these new rules are very helpful. Okay, up top we used implication, and we got not C or not C, and that's, you can get not C from that. So very helpful rule. And then we use implication again. We wanted to change the horseshoe in 5 to make it, because if you have it's not the case, and then in parentheses and a conditional, keep in mind that you can always change that to it's not the case, blah blah blah, or blah blah blah, in which case you can perform De Morgan's on it to get something closer to perhaps what you're getting. So I would always look out for that, a setup like number 5, because you can again apply this implication then De Morgan's and get 2 conjuncts and then simplify those conjuncts. So it's very helpful. Alright, so we're out of time. Hopefully that helps. Thank you.